Here is a sample substitution integration problem. This is out of the supplemental text we have available for the course from OpenStax Calculus Volume 2 by Herman and Strang. This little monster is problem 279 from Chapter 1. It's currently guarded by Spider-Man. This is sort of a inception substitution problem because substitution is going to lead to more substitution, so we get to practice it twice. So the only reason I have it covered is that I've prepared the second step for this, which is to highlight in light blue there a couple of the bits and pieces that we are going to hook into for our substitution. So if you're comparing, remember we're looking for outside functions, inside functions, and derivatives of the inside function to kind of line up the bits and pieces that will work for the substitution. We see an x squared in use here and here, and then here we have x dx, and so the x is related to the derivative of x squared. It's not exactly that derivative, but those multiplicative constants we can always deal with. So what we're going to do is simplify this by taking out x squared and replacing it with the simpler u. And with that choice of x squared equals u, we're going to get 2x dx equals du. And then we compare, well, we got that. Those are both going to turn into u's. And then we have to change all the instances of our variable. The x dx at the end there, well, it's not exactly du. The x dx that's sitting there is 1/2 du, and you could probably hear Zoe the calculus dog barking away in the background. There must be somebody walking by out front, even though the weather is cruddy. So with these pieces in mind, our integral is going to turn into the sine of u times the cosine of u times 1/2 du. And okay, a little tidying. 1/2 integral sine u cosine u du. So it's tidied up a little bit. And then we can just treat this as a brand new problem, right? Let's here bring back Spider-Man. Let's just forget everything that came before. Here's an integration problem. It happens to be simpler than the one we started with. And it turns out that this one is actually a substitution problem as well. Because, for example, if we say, look at this as our substitution, this is its derivative. In other words, if we say, well, we can't use u for our letter of substitution anymore, so let's say we're going to take this sine of u and send that to this new variable called w. Well, the derivative of sine of u is cosine of u du, and that's equal to dw. So here's the substitution. Derivative of both sides gets us that. And so this integral with that substitution is now 1/2 integral of w dw. And now we're ready to rock. This will be 1/2 times the antiderivative of w is 1/2 w squared. There's our plus c. We're almost out of space, but that's okay because we are almost done. That's going to be 1/4 w squared, which is 1/4 sine of u squared. But remember, u itself was hiding the x squared, and so finally we can put into play, I'll use a different color here to emphasize, hopefully it's not too light. Are we off the page there? No, we're not. Okay. And down here that's indicating it's the sine of x squared being squared. So we took the original integral, which is kind of nasty. We made one simplifying substitution, which tidied up a little bit. Now, did we really need to go through the formal substitution here? No, we didn't, but technically it is a substitution. Perhaps at this point you can just see that that's going to The antiderivative of this is going to be sine squared. It's also negative cosine squared. You could have gone that route too. But no matter how you do it, once you get to here, we're all good.